Okay, hello and good morning. Sorry I missed the stream yesterday. I was just I was working on something. I'll show it to you when it's more done. But I have also been working on all the changes we made here, trying to understand how state machines fits into like a global state management tool, like Overmind. And I made a couple of changes, like not API surface changes, but more how it works under the hood. So a really good example of where state machines becomes really tricky in actual applications. Like state machines are typically used for very specific things. Like you need some complex drag and drop, or maybe you have like some timing thing that like it's typically related to a single component, not the overall architecture of your app. Anyways, so where we can see this very clearly is in this action called, let's see, this action. So we have this action called add backlog item. And we know that this action can only run in our in the screen where we add a backlog item. But the point of state machines is to guard your logic. So it only runs when it should run. So what we do here, first of all, we have to check if we're actually authenticated in this app before we start running this logic. And then we have to check, are we actually on this backlog item page? Because that's where we intend to actually run it. And then we have to check on this page, are we in a valid state, which means we're able to click the button, or are we in an error state, which means the server gave an error. So it's not an invalid state, it's an error state, where we also allow you to click again. And then we can start actually doing something. So what we do is that we go down here and we grab the profile and the current description into variables, and then we start the transition into adding. So the add backlog item state machine goes into adding mode. And if that's successful, we start doing our side effect, which is basically creating the backlog item, which is this piece of logic. But now the thing is, we have done something async, which means that the application might have completely changed. Like in theory, like this is the problem with state machines. You do so much in theory that doesn't really happen in practice. But sometimes it, like the edge cases happens in practice, and that's where you get these bugs that state machines save you from. But the question is it worth it? Is it such a big deal having these edge cases? Sometimes maybe, but most of the time, I don't know. Like that's the thing, I don't know. But anyways, so we've suddenly done something asynchronous, which means that anything could have happened. The user might have moved to a different page. The user might have been logged out for some reason. Like we have no idea about this. So what we need to do now, we need to check, are we still in the state that we started out with? So the state we started out with was authenticated, add backlog item. We were in we changed to an adding state. So authenticated, add backlog item, adding. That's where we were when we started the async request. And we have to ensure that we're still there. Now the question is, do we have to check everything? Do we still have to check that we're authenticated and in the add backlog item page before we run this piece of logic? And the thing is, initially we did have to check that, because if you ran this matches, it would actually run even if the state machine wasn't part of the structure anymore, because you had changed page or you were unauthenticated, it will still run this because the state machine still kind of lived. Yes, but what I've done now, what I've done is that I've added this feature. There's two things I've done. So the first thing is I've made state machines disposable. And what that means in practice is that if we go to machines and we have our auth machine, which is at the root. So this is the top level state machine. And you can see when we're authenticated, it attaches the app machine. Okay. And if authenticated would move into any other state, it would dispose the app machine. Meaning that if you try to make another match, use the matches API or the transition API, you would actually get an error. It would say that, well, you wouldn't get an error. It just wouldn't do anything. That's the thing. Like, because it's not necessarily an error. It's just a guard that it shouldn't run the logic. And that means that if we are in, let's go back to the actions. That means that if we were down here, we had actually added a backlog item. And for some reason, suddenly we were unauthenticated. It will still run this logic. We can't prevent that. But since the add backlog item state is disposed, like the state machine is disposed, when it tries to run this, it doesn't run the callback because it's disposed. Okay, so that's the one thing that I did, and this kind of runs through the whole thing. So if the app machine is disposed, it will take a look at its own state machines and dispose them. So it kind of trickles down. And when it's disposed, you can't do anything with it anymore. So we're going to make a change here related to that. But then we have this new thing called strict. So I thought about this, like if you want to move into this whole state machine ordeal, you really want to do it properly. So I introduced this mode of Overmind called strict. And it's kind of funny because the initial strict mode of global state management is to only allow state mutations in actions. That's what MobX does as well. They have like this action decorator thing. And that's also what Overmind does by default. But now with strict mode, you're not even allowed to change state in actions, which might sound weird. But you actually have to use state machines. And to change the state, you have to explicitly run the matches API or the transition API. That's the only places you're allowed to make state changes. And that basically just gives you another level of ensuring that you only change state when you are actually able to do so and when you intend to do so. Cool. But what I said is when we change into authenticated, so on auth changed, if we have a user, we will move into authenticated. Now the thing is that we are just reusing the same machine every time we're authenticated. And we don't really want to do that because it might be disposed. So what we can do instead is that we call app machine, like create app. So we can say, maybe we can just call it that. Create app. And maybe this should be part of the documentation. That instead of exposing the machine like this, you say create app. And what this also allows you to do is to make it dynamic. So in this case, let's see, create app. We do this, we would be able to, based on the current authentication state, we would be able to pass arguments into this function based on our current state, which would put the app machine in different states, initial states, which is really nice. Okay, so we're going to do that, and then we're going to do the same to this one. Create add backlog item. And we'll do it like that. And let's move back to our actions. create backlog item like that. I'm not quite sure what it's yelling about, but we'll figure that out. And we'll do the same with create auth. Create auth. Like that. Create auth, and then in our we'll do it like this. And then we'll have to check why it's yelling at us. Oops. App auth. Oh, then we have notifications. Yeah, that's also something I changed off stream, is that our notification needs to be a state machine because it runs async logic, which means we, with our limitation, like strict mode, we can't just run some async logic because it first shows the notification, then it waits for a second, and then it hides it. But it doesn't really know what the state of the app is after that async wait. So we need to make it a state machine with two different states so that we can safely transition between them. Which sounds silly, like it's just a freaking notification. How difficult can it be? But this is the thing. Like, there is actually an edge case where you try to either show the notification or hide the notification where it doesn't make sense in the whole picture. And that's the whole point. But yeah, let's see. Where's notification? Oh, I think we're actually just using it inside app. Yeah. Oh, here we are. This is create add backlog item. Create notification. Notification, create notification. Yeah. Oh, yeah, this is why it's breaking. Yeah, so we have to, maybe there's a better way to do this. Let's see. Let's iterate a little bit more here. So we have this state machine, but we can actually export. Add backlog item. Export type. Add backlog item. It's a state machine of state and base state. I'm a little bit unsure how this works. Let's try it. Or my lib. Why does it want it from the lib? Why can't I? Are you kidding me? Oh, is it state machine? Oh yeah, it's state machine. Oh yeah, don't we have base? Oh, it's base first? Oh, that's silly. I should flip that around. I'll do that. But anyways, what if I do this? Does it understand? I don't think it understands this. No. Okay, so that's kind of dumb. Yeah, maybe we should just use the return type. I think we'll do that. Oh, did it import that? Anyways, so we have our create backlog item. So basically we want the return type of create notification. And we want the return type create add backlog item. Okay. Oh, didn't I remove that? Maybe I didn't. Auth, is it happy? Nope. create app, and then return type of create app. Cool. So now our actions should be happy, and we are back. So now if we are unauthenticated, it basically means it resets the whole state. And this is really interesting. Like, I find this super fascinating because this is the stuff we're not dealing with in our applications. It hasn't been this obvious to me before, because what we do is that we look at the code and then we look at it as boilerplate. And there is this balance. Like, this is the thing. Sometimes boilerplate is just completely unnecessary, but other times it is there because there is some hidden complexity in what you're doing. And again, pointing to this action of just adding a backlog item, there is a ton of hidden complexity there, because it's not only about looking at this page and doing the thing. It's the fact that you're not only on this page. You're either authenticated or you're not authenticated. Then you have like chosen the page, and then you are in a specific state of this page. And then you do the most complex thing you can do in an application, which is doing something asynchronous, which means that after that asynchronous thing happens, you might not be on the page anymore. You might not be authenticated anymore. So you have to ensure that you're still in that state before you continue running the logic that was intended with the state you started out with. And yeah, this is becoming more and more clear to me. And I think this is where I think I'm going to make like a tiny presentation on this, because this is what gets lost when David talks about state machines. He talks about impossible states, but at least for me, I have not looked at it like this ever before. And I think it's because XState and like the way you use XState, you also see it in the examples. They are for these small machines. It's not for these large, like you can think of your whole app as one machine with many tiny machines, but it's not really built for that. And you see that even though this is like an imperative approach, which you can argue is not the best way to go with state machines, which I partially agree with, because with XState, you're doing it declaratively, which has like some insane benefits of like you can read the state machine before it runs and all that stuff. But that declarative approach becomes insanely complex, talking about boilerplate. If you were to express the complexity of what we're doing here as like a state machine or a state chart, it would just be, it would feel just as boilerplatey as this, maybe even more. But that's kind of what I'm trying to do. I'm trying to find an API that gives you the most flexibility with the least amount of boilerplate, which is practical in the sense where you want to build your entire application based on this concept of securing your application states and the transitions between them. Okay. Yeah. So this is really good. I'm actually doing a stream later today with Evis in Codesandbox, and we're going to talk about this latest edition of the current state machines API of Overmind, and we're going to talk about this stuff. Oh, I have a meeting in 10 minutes. So what we're going to do, we are going to fix a bug, because I noticed that after we did our refactor, let's see, we have this thing where we toggle. Yes, we're toggling here, we're toggling the active weekday. Hello, and if I go here, it doesn't look like it's not active for some reason. So let's see what's happening here. So we are going to app back current selection, and we are pushing to active weekdays. App, add backlog item. It's kind of nice. You actually see the state machines and what state they are in. And I really like this. Like it's complex. But yeah, we talked about all this. I'm not going to talk more about it. Anyways, so we do have our active weekdays there. So I do wonder why it doesn't. Because we have. Oh, we're pointing to state. And we do have the state of the add backlog item. And we are I'm concerned now. And we are passing in the active weekdays. Oh, we're not passing in the color. That's the thing. I remember now. So it's actually there. It's just that we added this color thingy. And what did we do? We get color. No, what was the name of our utility? String to color. String to color, and we actually use. And did we have a derived for that? We have profiles, but we want to use your. Yeah, string to color. So we can say root state. Oh, come on. Oh, is it? I need to turn that off. It's on every preview on edit. I don't want that. I want to explicitly save. Yeah, so this is also interesting. Yeah, exactly. Because we're checking here if the root state is authenticated. So this is also complexity. Like every single component, and this is where you also feel it's boilerplate. So in a component is not rendered in isolation, but it's defined in isolation. Which means that if you're going to do anything with any component, access any state, you really have to check if you're authenticated first. And that is completely unnecessary from this from the perspective of, okay, when you render your app, you would never get to this component unless you're actually authenticated. That's like high up in the component tree. But in the component definition, it has no idea about this. And you could argue that maybe you move this component to a different part of the tree where you didn't have this authenticated check higher up in the component tree. So you can think about a component just like an action. Each component/action needs to identify what I'm doing here. Is the application actually in the correct state? It's very interesting. It certainly is. So you could, but that's also a thing that got me thinking is components could be these very natural state machines in terms of disposing. Like when the tree changes, it disposes components, which would dispose the state machines. The thing is that components aren't rigged for communicating effectively with each other. You have to pass these props down, and a component is typically like for rendering. It's not for just defining some piece of state. And then you have these hooks, and it's just really difficult to ensure that the part of the UI that needs access to state actually gets access to that state effectively. And when they want to make changes to state, they also effectively have to do that. So having this decoupling requires you to treat components and actions in isolation, where they are themselves responsible for checking if the overall application is in the correct state. But you can move things around freely. It doesn't matter where it's running, and you will get the correct behavior. That's the thing. It's complicated, like application management or like coding and structuring. It's super super difficult. Anyway, it's profile UID. That's where we want to grab the color from. Oh, so there we go. Now we have the color. Great. Cool. So this was actually working. It was just missing a property. Okay, and we are back to our app. So what should we do now? What's our next step? I have to get ready for a meeting, but maybe we can maybe I don't know if it makes any sense to start out with anything more. Maybe we can just talk about our next step. So again, I'm like doing state machines for this application is, I don't know, is it overkill? Is this how, like, I'm not saying we should use this API. I just mean conceptually. Should we do all these state checks before running our logic, especially asynchronous logic? Is that a good thing? And should we automatically dispose of, or that ties into checking. So generally, should we have all these boilerplatey checks to ensure that we can actually run the state changes that we want to? Are they like valid? Is it worth it? Because as I said, like getting into impossible states, it's possible, but I consider it edge cases, or it would be way more problematic when we build our applications. But still, there's so much stuff you don't know about. So you always, as a developer, you always test the happy path. And then everything seems to be working, and then you push it into the wild, and then all crazy shit happens, all kinds of crazy shit. And you get into these weird scenarios. For example, when we were trying to add the backlog item, maybe for some reason you got unauthenticated, and then it was trying to like add that, like change the state of that page, but you weren't able to do that because you weren't in that state anymore. So maybe you would, I don't know, you would kind of add something there, and then maybe you logged in with a different user, and then you would suddenly have the items of the previous user, that kind of stuff. That's what happens in real life, these crazy things. So having a way of writing our application code that just automatically deals with these crazy edge cases, that's appealing. But I think that's why state machines as like a more of a global concept for creating applications isn't getting any traction, because it's like washing your hands. You're writing these boilerplate checks all the time of, am I in the correct state? But you don't get any instant value back. You will probably never get into a scenario where you think, oh, thank God we used this boilerplate code, because that ensured that we didn't get into that scenario. Because the complexity of your app makes you unable to see how you can end up in those states. That's the whole thing. So it's kind of like washing your hands, where you know it's important to wash your hands, but you'll never get into the situation like, oh, thank God I washed my hands that day because I poked at something, I had some bacteria or whatever. That's the thing. Anyways, I have to go into the meeting, and I'll talk to you tomorrow or on the stream later today. Bye for now.